Okay, guys, today we are going to be learning about the types of acids and bases. Mainly, they're looking at strong acids and bases and weak acids and bases. And then that's going to be very important for the other thing that we're going to do today, which is to write complete ionic and net ionic equations for neutralization reactions. It's not very difficult. You'll just need a little bit of practice. So first thing we want to do then is look at types of acids. A strong acid is an acid that is a strong electrolyte, meaning that it ionizes 100% when you put it in water, and it forms a solution that will conduct electricity very easily. And there are 6 common strong acids. That is going to be your HClO4 or perchloric acid, HCl, which is hydrochloric acid, HNO3, which is nitric acid, H2SO4, which is sulfuric acid, HBr, which is hydrobromic acid, and then HI, which is hydroiodic acid. So that's going to be very important for when we get ready to write our complete ionic and net ionic equations, is we have to know those acids that are strong acids because they do ionize completely in water. And so we will have to show in the equation that we write that they do ionize. Weak acids, on the other hand, are weak electrolytes. This means that they do not ionize 100% when they are put in water. They will, partially dissociate. They will partially ionize, but not completely. And so when we write these in a complete ionic equation, they do not dissociate. We do not show them ionizing. Some examples would be the HC2H3O2, which is acetic acid, and H3PO4, which is phosphoric acid. Acetic acid is vinegar. Okay, you know that is not a strong acid. H3PO4, phosphoric acid, as well as carbonic acid, which is H2CO3. Those are actually found in colas, so you know they're not strong acids because if they were, you would not be able to drink them. Again, we've already talked about this a little bit yesterday, but we can have acids as far as the number of protons or hydrogen ions that they contain. A monoprotic acid is going to be something like HCl, HBr, HClO4. They have only one proton to donate, whereas polyprotic acids have more than one proton they can donate. So any acid that has more than one hydrogen ion. So for example, H2SO4, H3PO4, H2CO3, these are polyprotic, and again, they can act as acids and bases. If it's donating a proton, it's an acid. For example, the H2SO4 can donate a proton, making it an acid, and it will become HSO4 minus. But then that HSO4 minus could actually accept a proton and become H2SO4 again. So it can act as a base in terms of it can accept, once it's lost a proton, it can turn around and accept it back to become this original acid, and so it could act as a base. Now, that really doesn't have anything to do with the strong and weak acid and bases. The number of hydrogen ions really doesn't determine whether it's a strong acid or base. So again, the main things that we're concerned about here are going to be the strong and weak acids. We have 6 strong acids that we will show completely ionize when we put them in our equation, whereas our weak acids we will not show completely ionizing, so they will not come apart in our equations when we write them. Okay, likewise, we have strong and weak bases. A strong base, again, like a strong acid, is a strong electrolyte, and it will ionize completely and produce a high concentration of OH, or hydroxide ions, in solution. Your strong bases pretty much are going to be hydroxides of the active metals in groups 1 and 2. So again, group 1, on the periodic table, that's going to be the first column. Group 2, the second column. Both of those columns of metals, when those metals combine with OH, hydroxide, they form a strong base. So again, things like KOH, NaOH, LiOH, all those are group 1 metals. So these group 1 metal hydroxides are strong bases. These are not the only ones, but these are examples. And then our group 2 metals, such as our Ca, our Ba, our Sr, some of those that are in group 2 are strong bases when they combine with hydroxide. So these group 2 metal hydroxides are also considered to be strong bases. So if we have one of these in our equation, then we will write it out so that we demonstrate that it ionizes completely in solution during the reaction. On the other hand, like weak acids, weak bases are weak electrolytes. They produce a low concentration of hydroxide ions, and so they do not completely ionize in water. And so when we write these in our equations, we will not show them ionizing. We will not show them ionizing completely. So what we're going to be looking at here are neutralization reactions. Basically, it's when we have our hydrogen ions, or remember H3O plus is the same thing as a hydrogen ion. It's H2O plus a hydrogen ion, which we call a hydronium ion. So hydrogen or hydronium ions and hydroxide ions react. They come together to produce water. These are special kinds of double replacement reactions. Again, remember in our reactants we have our acid and our base, and then in our products we're going to have a salt and water. So in this case the H and the NH switch, or the Na switch places, and so the Na goes with the Cl and we get NaCl, and then the H goes with the OH and that gives us water. So HCl is the acid because it's donating a proton, and then NaOH is the base because it has hydroxide. Remember, we're actually using the Arrhenius definitions here. Anything that produces hydrogen ions is an acid. Anything that produces hydroxide ions is a base. So this is our acid, this is our base, and we get a salt and water. Okay, so what we're going to do when we write these ionic equations is we're going to write all of the strong electrolytes as well as the salts in their ionic form. Anything that is a weak electrolyte or is a solid or a liquid or a precipitate or what we would call an other material will not completely ionize, and so we would not write it in its ionic form. So in this example, again, we're going to do acid plus base gives us a salt plus water, okay? So HNO3, if you go back and look, it is on our list of strong acids, so it will completely ionize. So when it breaks apart in water, it forms H plus and NO3 minus, which you can see right down here, and this stupid thing keeps getting in the way. Let me see if I can just escape that. There we go. So the HNO3 completely ionizes since it is a strong acid, so we write it as H plus and NO3 minus. Basically, we're just breaking apart the ions that make it up. So HNO3 is made of H plus and NO3 minus. And then KOH, again, that is a group 1 metal hydroxide, and so again, it is a strong base. So we would write it in its ionic form because it does completely ionize in water, and so it is made of K plus and then OH minus. And then at the end, salts are also strong electrolytes, and so therefore it does ionize completely in water. And so KNO3 is made of the K plus ion and the NO3 minus ion. And then water is a liquid. It's an other material, so it will not be written in its ionic form, so it remains as H2O. So this is what we would call our complete ionic equation. It's basically where we've taken this molecular equation, we've taken this double replacement reaction that we have, and we have broken all of the strong electrolytes, including the salt, into its ions. So we have broken it up into the ions that make it up. And so this would be called this is our molecular, that's just our regular double replacement reaction, and then this is our complete ionic equation. Now we're not done yet because what we want now is a net ionic equation. So what we're going to do to get the net ionic equation is we're going to work with this complete ionic equation. And what we're going to do, we're going to mark out any ions that exist on both sides of the arrow. And basically these ions that we're marking out, we call these spectator ions. So we notice that on the left and right of the arrow, we have an NO3, so those get marked out. On both the left and the right, we have a K+, so those get marked out. So after we mark out the spectator ions, again, these are the ions that are on both sides of the arrow, then what we have left is our net ionic equation. So on the left of the arrow, we have H plus and OH minus, and then on the right of the arrow, we have H2O is the only thing that's not marked out. So our net ionic equation for this reaction is H plus OH minus yields water. Now, I will tell you, anytime that you have a strong acid reacting with a strong base, this will always be your net ionic equation. Okay. Now, if you have a weak acid or a weak base in here, then this will not be your net ionic. But anytime you have both a strong acid and a strong base, they will both completely ionize in water, so you will break them apart into their ions when you write that complete ionic equation, and you will end up with this net ionic equation. Okay, so let's look at one that doesn't have a strong acid and a strong base. So here's another neutralization reaction. Again, acid plus base gives us a salt. This is our salt plus water. This again is our molecular equation. So when we look at HC6H5CO2, okay, that is an acid that is not on our list of 6 strong acids. So therefore it is a weak acid. So notice in our complete ionic equation we do not break it apart because it does not completely ionize in water. NaOH, this is a group 1 metal hydroxide, so it is a strong base. So we do break it apart into its ions. So it's made of Na plus and OH minus. This is a salt, so it does break apart into its ions. It's made of Na plus and C6H5CO2 minus. And then, of course, this is water, which is another material or liquid, and it does not ionize, so we leave it as H2O. Okay, so now this would be our complete ionic equation. And then notice what I have done here. I have already marked out the spectator ions. So again, we do have an Na plus on both sides of the arrow, so those mark out, but that's the only one that marks out. So what's left after we mark out the spectator ions? HC6H5CO2 plus OH on the left. And then on the right, what's left is C6H5CO2 minus plus H2O. And this would be the net ionic equation for this reaction. So again, if you have a strong acid and a strong base as your reactants, then this will always be your net ionic equation. But if you don't have both a strong acid and a strong base, for example, here we have a weak acid, then notice how our net ionic equation is different. All right. So what I want to do then is I want us to look at some more examples. Now you have, this is going to be your assignment, and you will see here that I have the rules here for what ionizes and what doesn't. So this is the form that you will have, that you will be doing for practice to turn into me. You can either type it on here, or you can print it out. You can fill it out with pencil and then take a picture of it and submit it to me. Either way you want to do it, but you can type on this form. So let's go ahead and look at another couple of examples here. Again, I want to remind you these are the rules, and they will be also, as you can see here, on the document that you will be completing as well. But again, all salts are strong electrolytes, so they will completely break apart, and you will show that. Remember, the salt is one of the products. The other product will be water. Most acids are weak, but we do have 6 strong acids. So if it's one of these 6, then you will show it breaking apart into its ions. If it's not one of these 6, then it doesn't break apart. So you leave it together when you write that complete ionic equation. And then bases, again, remember group 1 and group 2 metals, hydroxides are strong bases. So I might even put that there. Group 1 and Group 2 metal hydroxides are strong electrolytes. They are strong bases. So if it's not a metal hydroxide with a metal from Group 1 or Group 2, then you're not going to break it apart. If it is a hydroxide from a Group 1 or Group 2 metal, then you will break it apart into the ions that make it up. And then any other material is a non-electrolyte. So again, things like precipitates, liquids, solids, things like that. So if it has an S after it or an L after it, then it's not going to be a strong electrolyte, and you will not break it apart. You will leave it put together. So now what I'm going to be asking you to do if you look at yours is you're going to have to also predict the products. Again, remember these are double replacement reactions. Do not forget to balance the equation before you do all this. So I want to go down here and find, let me see if I can find an example. We may just go ahead and just do this first one here for you. That's actually on your document. So we'll do the first one together. And I'm going to bring up let me go ahead and write this down. Hold on just a minute. I'm going to write it down on my iPad so that I can demonstrate it to you. So AL, if I can get it to write. I do not like this program very well, but it's the best I have right now. AlOH3, which is a solid, plus HCl. Okay. So now let me go ahead and get it over here to my screen. Well, I don't know where it went. It was here earlier. I think I'm losing my mind, guys. Sorry. Okay. It was connected earlier, I think, because my iPad went to sleep. Okay. Sorry about that. All right. So first thing we need to do is we need to predict the products for this reaction. Again, this is a double replacement reaction, so the Al and the H are going to switch places. The Al will go with the Cl, and then the OH will go with the H, and we'll get H2O. Now, the other thing here that is important is that we write the correct formula for this reaction. So Al is positive 3, Cl is minus 1, and so our correct formula for the compound that has aluminum and chlorine is AlCl3. So do not forget when you're predicting these products to write the correct formula, okay? So now that we have written the formulas, the correct formulas for our products, we predicted our products, now we need to balance this equation. All right, so to balance this equation, it looks like we're going to have to put a 3 here and a 3 here. So don't forget to predict the products, write the correct formula for the salt when you predict the product. This is a double replacement reaction, and then don't forget to balance the equation. All right, so now that we have written a correct balanced equation with the products, now we're ready to write our complete ionic equation. Okay, first thing I notice here is I have AlOH3 and it's a solid. Well, what did we say about solids? Solids are non-electrolytes, so they will not ionize, which means we will not break it apart into its ions. So we are going to keep AlOH3 just exactly like it already is. So we're not going to break it apart. And that should be a 3. All right. Now, HCl, is it in our list? That is our acid. That's HCl is hydrochloric acid. Another thing here, guys, even this AlOH3, even if it were aqueous, okay, aqueous means it's dissolved in water, it still would not ionize because aluminum is not a group 1 or group 2 metal. Aluminum is a group 13 metal. Okay, and so therefore this is not going to be a strong base. So even if this was aqueous instead of being solid, it still would not ionize completely. So we would not break it apart. We would still write it as AlOH3 because aluminum is not one of those group 1 or group 2 metals. Okay, HCl, hydrochloric acid, is one of those 6 strong acids. So it's going to break apart into its ions. Well, 3 hydrochloric acid molecules will have 3 hydrogen ions and 3 chlorine ions. So we're going to write this as 3. Again, we're taking into account that there's 3 there. There's a 3 here. 3 HCl's is 3 hydrogen ions plus 3 chlorine ions. All right. So that's on the left side of the arrow. Now let's look at the right. AlCl3 is a salt. And so, therefore, it is an electrolyte. It will ionize completely. So, Al, what is the charge of Al? Well, it's plus 3. Okay. And then we have 3 chlorines. Well, we know chlorine is Cl minus 1, and there's 3 of them. That Cl3 means there's 3 chlorines. So, 3 Cl minus 1. And then, of course, this water is a liquid. That's a little L is what I put there. So H2O, and that's a liquid. So that is our complete ionic equation. So I'm trying to make a line here. This is our molecular. Sorry about that. And then this is our complete ionic. Okay. Now, to get our net ionic, remember that we have to mark out the spectator ions. So, any ion that's on both sides of that complete ionic equation, we can mark out. They cancel each other out. So, you will notice here that the only thing that I have that's the same on both sides is the 3Cl minus. I have 3Cl minuses on the left side of the arrow and on the right side of the arrow, so I mark those out. There's nothing else that I have on both sides of the arrow except for the 3Cl minus. So those mark out. And our net ionic equation then will be Al OH3 plus 3H plus yields Al plus 3 plus H2O, which is a liquid. All right? And there is our net ionic equation. So I've just done the first one for you. And something else you will notice, guys, when you do this assignment is that I have the correct answer right here for you. All right? So once you have done this, this is what you should get. But you want to make sure that you can get that, okay, on your own. So I have the answers on here for you so you can check yourself. So don't just copy and paste, because you have got to fill in the molecular equation like we just did. That means predicting the products, writing the correct formula for the products, and balancing the equation. Then you've got to do the complete or total ionic equation, where you break all of the strong electrolytes, that's your strong acids, your strong bases, and your salt, into the ions that make it up, and then get this net ionic equation. And this is the answer that you should get once you have marked out the spectator ions. Those are the ions on both sides of the arrow of the total or complete ionic equation. So, please let me know if you have any questions. These are for practice. Again, if you have questions, go back, watch the video again, email me and ask me a question, or email me your number and I can FaceTime you and we can go over another one together and make sure that you understand how to do this. Again, you are going to have, I'm actually giving you a couple of days to do this, so that way you have time to watch the video and practice, just in case it takes you, a little bit of time to figure it out. But again, that is why I have given you the answer to each one of these, so that you can see what you should be getting after you write all of this out. I hope you have a good day, and I'll be talking to you again soon. Bye-bye.